for a particular patient or a particular set of a data. Now, the question is why this is so much important. Okay. Just 1 second. Just give me 1 second, guys. So small. Yeah. So okay. Is it visible in the large scale now? Can you please confirm?
Now slide is moving, sir.
Okay. Okay. Yeah. So why? So I was saying why it is important for us to understand the epilepsy here, because considering there are like large population all around the world which is suffering from the epilepsy, which is almost, if you accumulate all the number, it will come around 5 crore or approximately 50 millions of people. Now this is an overview why we really need to understand the epilepsy and how we can use AI. Now, before we enter more into detail, what is the epilepsy and what is the EEG, we need to understand how our brain functions. Now, whenever we do any type of an activity, our brain generate a biosignal, which is basically nothing but an electric signal having a 3 major component in this one, being a frequency, amplitude, and the entropy. Now, frequency is nothing but a number of time it go up and down in between given period of time, and the amplitude is the height of the particular signal. Entropy is the how random the signal is or how constant the signal is. Right. So we need to understand that part. Without understanding that, we will not be able to move next. So that's why this a little bit understanding of how brain works is important. Now we will move to the epilepsy part, right? So it's nothing but recurring seizures that our brain produce unwantedly. Which what is seizure here is it's like an electrical activity which brain not supposed to do, but due to some issue with the brain functioning, it is keep on generating. It could be in a small area also. It could be in a bigger area also. So when this type of seizure happen over a period of time, this is also called as in large scale as a epilepsy. Now, to understand to the next level, we need to understand the EEG. EEG is is nothing but an electrical activity of the brain, which we usually record using the electrode, and which is very important for us to detect the seizure. Now, why? What are the? We need to understand the more in detail, like why it is challenging to understand the signal which our brain produce, which is basically EEG, are very low in amplitude, like somewhere around few millivolt, and very low in the frequency. So it's more to that, considering it's very difficult to stay stable. We have a noise also in that. Noise could be a movement noise could be an eye movements or some other muscle activity. So those are the major challenge which are being faced to understand the epilepsy, right? So now, if you will, the epilepsy actually have a multiple type, but if you ask me in the large scale, which basically cover 90% of the cases, are only 2 types. One is the focal type, another one is the generalized type. So now focal type cover 60% of the cases, which is we just discussed, like around 5 crore. 60% of that will be mostly are the focal epilepsy. Now how it works is this will start generating from a particular part of the brain, and then it will trigger an unwanted signal which will affect the sensory as well as the motor part of that. Due to that, what will happen? The patient or a person will do unwanted movements, maybe hand moving, doing random activities. So that's a focal, which is being generated in a particular part of the brain and affecting the motor, sensory, and other system of the brain. Now, second one is the generalized epilepsy. Now, as name itself suggests, this is something which happen all around the brain. All part of the brain will generate all type of unwanted electrical activity that will cause a unwanted body movement. It could be in hand, legs, or some muscles, maybe eye tweaking, something like that. Now, okay, so as at this stage now we know, I mean, what is the epilepsy, and then what causing it, and how our brain generate the signal. We need to understand how AI can help us to analyze the signal, better than a human can do it. Now, AI is a very large scale expert on handling a large scale of a data. If and human brain, if you ask me, like, or if you give them a little bit of data, it'll take a lots of time to analyze. They have to go through the lots of information to do that. But AI, considering it could be an expert in that particular area, can largely handle all the data and can easily maintain or separate the noise from the required signal. Now, after giving enough training, it can easily detect the pattern also from the EEG signal, which is very important for to understand whether the person is going to have or on process of having a epilepsy or a seizure. Okay, and another advantage is, considering it's a very powerful and designed for us. We can design it for a specific function. We can detect it on the real time. Okay, so these are the four things we need to consider before going to analyze the data or applying an AI algorithm or a model. First part in that one is the data collection. Now, data collection is done by the ECG device, which is a basic electronics device which will be connected to the electrode. With those electrodes, will put it on the brain. Those electrodes are highly specialized electron which can detect the minimum voltage. Those electrodes will take an analog data and feed it to the processing system, which is the processing system. What it will do, it will remove the artifacts if there is a motion artifact or the eye movements or any other type of, and it will remove all other kind of a noise. Now, pre-processing we will discuss in the next step also a little more in detail, but this is a very basic of like what is the meaning of pre-processing here. Now, next one is the feature extraction. Now, once we have an EEG signal, which is basically an amplitude and frequency, we need to separate it in the two forms. One is the temporal, one is the spatial. Now, temporal forms are nothing but the amplitude and the frequency side, and the spatial form are nothing but which relate to the space. Like, for example, what electrode we are getting, what data we are getting from the electrode 1, or what data we are getting from the electrode 2. Now, once we have all those information, then come the model training. In the model training, we can use very basic signal processing, or little more of a machine learning, or even more of deep learning that we will discuss in the next with a few example how we can use those. So these are the four basic steps. If we are we're planning to make any such a device which can help us to understand or pre-detect the epilepsy, these are the four basic parameters we need to go through. Now, as I said, the pre-processing has basically two main parameters. First one is the noise removal. Now, as considering it's a very low in frequency and the amplitude, there are very high possibility of having a noise to that. So we have to make sure that we should use some specific type of filter so that AI don't have to do that. For example, now we know that like eye movements, due to the eye movements, we generate a specific amount of frequency. Those frequency we can easily remove by putting in a band pass or low pass or high pass filter based on the different type of frequency which is generated by the different movements of the body. Now, next thing what we need to do is segment it. ECG signals are like large scale. If you have a device which can take lots of data per second, we need to segment it so that the AI model which we are going to discuss in the next can easily predict it over a small period of time. Like, so to make it a better understanding, we can subdivide the signal into 1 to 5 seconds. Usually it is helpful to have not more than 2, but if it is a very complicated, we can go up to the 5 also. Now in this section, we will be discussing what are the different AI technique we can actually use to extract those information at the different level. The simplest level being a signal processing, where we can just simply make a small model which will just analyze the signal which is coming from the device, and it will predict a basic parameter of that, and it will tell us whether it is it is possible to epilepsy or not. Now, this is a very base model. It's a very, there's no learning on that one, or there's no, pre-analysis or pre-modeling of that. Now, if we will, this is the very basic model. If we will increase the little more complexity, we can design a machine learning model, which has a different technique, which we'll be discussing in the next slide. So this is a little bit more into more to the signal processing, where we will be. If you ask me the large scale, it will be like you know the signal, you know what are the possible pattern, you verify one by one pattern, and then you say whether it's an epilepsy or not. That level. Now then come the next thing, also deep learning. Now that deep learning make it more robust, because in this one we can use a neural network. Now the advantage of having a neural network is because it's like in a memory based system, where whatever it happened, it can remember the previous information in the same sequence which happened in the previously, and it can use this, that particular knowledge to find out when this type of event happen again. Right. Right. So first thing on the signal processing side. So first, when for the signal processing, what we do on the first step is, we will first remove the noise, and we will have only as much as possible good ECG data. Now, removing a noise is very important for the signal processing, because it cannot differentiate between the sometime actual ECG signal and the noise, because it has no memory or any model to remember it. Once we can do that, we can extract three major features, which is we're going to use in the next step also. The first step being frequency, which is how many time up and down happen within a period of time, and then the power, which is nothing, the amplitude at that particular frequency, and the entropy, which is what is the randomness or the continuation of the same type of pattern. Now, once we know that, and once we know that we know this particular parameter, then we can use the signal processing mechanism to find out whether the signals which we are receiving is same as the normal signal which a brain generate for a normal activity, like when we are sleeping or when we are doing XYZ activity, or it is something different. It can give us that level. It cannot, at this stage, we cannot predict whether it's really a epilepsy or not, or a seizure activity or not. Now, so this is a very basic model. Now, this is a more advanced version, where we can use an AI, is the machine learning approach. Now, in the machine learning approach, we can teach our system based on the data we already have, so that when this type of event or this type of frequency happen again, our system can easily predict whether seizure happened or not happened. Now, there are based on this priority and advantage, there are three major techniques we can use to identify that. First one is support vector machine, then second one is decision tree, and third one is the random forest. Now, so support vector mechanism is usually called SVM, which we'll discuss in detail. If you ask me, so this is how, we are going to understand how we can actually use the technique. I'm not going to go in like much detail, how to write a code or the algorithm for that. But this discussion will give us an idea about how our algorithm should be, which direction our algorithm should be working on, right? So now, while talking about the support vector machines, what this particular mechanism or the algorithm does it. This particular algorithm can especially designed to differentiate between two different type of data, and it can easily make a boundary in between. So in our case, like for example, there is an EEG data and EEG data which having a high frequency or high amplitude. So this technique can easily help us to differentiate or make boundary between the both of them. Now here we will take a simple example. Now, based on our own data and own learning, we know that if whenever this type of seizure happen, our brain become very highly active. right? So, and when our brain is highly active, that means it's going to generate a very high type of frequency. Then second one is when this type of happen, the normal brain, our brain wave will not be normal. It will be like unpredictable kind of. No, it may happen now, then it may not happen. Then it may happen again, it may not happen again. And then third one is the power, which is nothing but the amplitude. Amplitude may not be the same as it's supposed to be for the normal functionality. It will be like high spikes will be there. Now these three parameters we can set for a particular algorithm. Once we set this particular parameter, what we can do is we can design or write in our algorithm saying, let's say for example, if the for this study, that this particular data set, we says, okay, if the entropy is above let's say 5 and the frequency is above 7 or something like that, or maybe 8, we have to consider it is not a normal brain activity. We have to call it as a either it's a seizure or non-seizure, right? Now let's go through the, like, that's a simple example here. Suppose our data collecting system detect there is a high frequency data I'm getting it, and the entropy of the signal, which is nothing but the randomness of the signal, is very high, which is 0.7. Our system will say, okay, it's a seizure. If it is low, which is let's say 5, and entropy is 2, which is which is not random, it's constantly happening from over a period of time, that means it's a non-seizure. So like that, once we set this type of a parameter based on our previous learning in this particular mechanism, this will help us to differentiate between the seizure and the non-seizure, which could be a good model to automatically analyze the data continuously or over a period of time and differentiate between which signal have a seizure or which do not have it. And the next level on this one is the decision tree, right? So this is more or less same as the previous one, but why it's called decision tree is because in this one it is not going to check only this particular parameter. It's going to take a decision based on the each step, and it's going to check each step one by one. For example, I will take same example here. So what our parameters are set. Like for example, we can say it like if the frequency is high, higher than the normal seizure, normal activity, and the power of this is also high, and the entropy is also high. This is going to be. So we can design algorithm using this particular method, where in every step we have our conditions. If this condition match, yes, go to the next condition. If this condition did not match, it's not a seizure. Stop there. If the second condition also match, go to the third one. If this condition match, this is a seizure. If it's not, then it's not a seizure. So that's why in this technique, every step we have to define a parameter based on our previous experience or the data analysis, saying these are the parameters. If whenever this happen, you have to say it's a seizure, and at the end of it, our model will tell whether the person had a seizure or not. Now, next one is a little more advanced version of this one, which is basically a random forest, right? This is a technical name of that. So what this one will do is it will create a multiple decision trees, which is previously we had it. So for a simplest understanding, we'll take like some real life examples, not necessarily to be EEG related. So let's say for example there's some theft happening somewhere. You hire some 10 police people or someone who usually find out what went wrong there, and you send each of them to go inside the room and give you their decision. Each one will use a different parameter, and the end of it they will be able to tell whether the actually theft happened or the person is lying. Same technique is used in the random foresting, where you set lots of parameters and then you let the model to go through all the parameters continuously, and then end of it you see how many of those tree have said whether it's a seizure or not seizure. If majority of them says okay, they end up with a seizure or 1 or zeros. If majority of them says 1, that means the person's or the signal or the particular patient is going through the seizure. Otherwise, it is not. So these are the machine learning, the mid-level algorithm we can use or design to find out whether the person or a particular signal having that sample of the seizure or not. Now, Next one is the deep learning. Now in this one, we will be using a previous data technique, but in this one, we will be using a memory also. Like, it will remember the previous data also. It's like consider, a technical name is RNN or recurrent neural network. So what this basically does is, it will analyze the data based on the parameter we'll give. The same time, it will store the previous sequence of the data. Remember, not just the data, what was the sequence of that particular data, and whenever required, it will use that sequence as well as the parameter has been set in the in this one to find out whether the particular signal have the seizures signal or not. Now, so this is how this recurrent neural network understand based on the data. Now we will try to understand this thing with a simple example here, how we can design a simple RNN for epilepsy detection. So in this one, first step will be the input data. Now, first we will feed the input data, and when we are going to feed this data, we have to make sure, considering it's going to store it and analyze it both in the same time, we have to divide this data into two things. First one, we have to subdivide whatever the set of data we are having into the small segment, so that it will not have unwanted load. So it will go step by step, and then we need to define our features. Like, for example, what are the frequency set we are saying, above this is the seizure, what is the amplitude we are saying, and what is the entropy we are saying. This parameter, if they match, it has to be considered as a epilepsy or seizure. Now, what advantage of this particular thing compared to the previous technology is memory. Now, it's not just use that particular data we give it, it will also remember the previous sequences also. But one thing we have to do in this part is, whenever the previous sequences has, we have to tell the system, this sequence, it was not a part of our the data set which we share, but it was actually a seizure. So it will remember that particular pattern also, and it will use those self-learning based on the continuous feedback plus the previously fed data, and it will keep on improving to give a better result over a period of time. So this is a deep learning or RNN technique we can use to analyze the data and find out whether the person is going to have a seizure or is going through the seizure. Now, so while we were discussing all these parameters, there are few things which we really have to focus on, because this is one of the EEG is one of the signal where we have very weak signal and with having a very low frequency and the amplitude. So that's why the accuracy of the model which we design is very important, so that every time when it predict, it should be able to predict seizure and non-seizure properly. Then we need to make sure it is sensitive enough to actually detect it. So it should not be like which is detecting so many time of falsely non-seizure where it was when seizure happened but it detected it did not happen. It has to be very sensitive to the model, has to be very sensitive. And then third parameter is specificity. Now specificities are basically important here, because our model should be able to find out the false alarms. It should not happen, if we will design a model or a system which, randomly detect seizure or, non-seizure, that thing will have no value to the metrics. Now, the precision. The precision is basically nothing but the ratio, like how many times it has been accurate. Now, these are the basic parameter. Whenever we design anything, we have to go through it. So, how to achieve that is we have to give our model, whatever model we have decided based on the study, more number of data, data set. We will give it to that, more accurate it will be. Now, saying that, so that's why that's the whole reason behind the AI could be a very helpful tool here to predict epilepsy from a human signal, which can help a person to take a medicine on time or before time, or even a doctor can also take an input based on that and prescribe some medicine. So yeah, so this is something from me at this stage. Thank you. Thank you. I have tried to make it as simple as possible. It solve the purpose. Yeah. Thank you.
Thank you, sir. Over to participants. If you have any specific queries, the participant can interact and ask. Thank you, sir. We have no. Let me say to add advantage to the participants. Some benchmark data sets are University of Bonn has provided a benchmark data set where you can see three different types of signal: ictal as well as interictal signal, normal. Ictal signal is the one which is collected during the seizure.
Yep.
So interictal signal, the patient is epileptic, but during normal course of time, the signals will be collected. So there the thing is the differentiation between the interictal and normal. So that kind of thing. Another thing, University of Temple University, they have also provided some benchmark data sets with the various classes with for different classes are available. That you can Physionet is also one of the data set which is providing the benchmark for epilepsy seizure. As the speaker said, we have in Physionet with the classification like focal and non-focal signal also. Some of the data sets are providing with focal signal, non-focal signal, indicating that which portions of the brain is responsible for epilepsy, the region we are trying to identify with the help of the focal signal. I hope these benchmark data sets will be useful initially for the design, and we can use real-time data for validation.
So yeah, so I think Mr. Rohit have asked a question whether we can find out the source of epilepsy using the EEG. Now, so shall I go ahead, sir?
Rohit sir, you can unmute, you can ask even.
Okay. No, I think he has asked through the chat. So shall
Okay.
I? Yeah. So I mean, yes, at some level we can do. Now the how we have to do is, so what happened if it is generalized, we need to understand the center point of that, right? So and what so let me put this way, right? So each part of the brain controls specific thing in our body. Now let's say, for example, a person is having a left hand movement at a specific frequency, at specific pattern, that most likely to be a particular part of the brain have generated that unwanted signal. That's why the particular motor of that the overall system is behaving misbehavingly. From that pattern, we can identify from where it has been generated. And at the end of it, we really need data for that, so that we can train our model. But yes, once we understand which part of it is effective, we can definitely find out where it started.
One more question in the chat window for EEG signal processing, is RNN or CNN better?
Okay, so it's see, my personal view is on the RNN. So considering we can remember a little bit more, it can remember the previous memory, and we can it's like continuous learning process. So just this is only the parameter. And being a little bit honest with you, I haven't gone much into the CNN. When I was going through all these things, I was just reading through, okay, which make more sense, or the continuous learning and other things. So I did not went too much into the CNN, but from the RNN, I understood it could be a very helpful tool, to go into the deep into and make better prediction. Yeah.
Generally, for time series data, RNN may be better
Yes.
rather than
Yes.
one-dimensional CNN.
Yes, CNN is usually, to my understanding, I think CNN is used for an image processing at some level.
Image also, we can also use one-dimensional CNN. 2D
Okay.
CNN normally for images.
Yeah.
We can have one-dimensional CNN, but normally recurrent neural network based framework is used. It is actually many to one classification. Time
Yes.
series data we can give as such without extracting any features. Even instantaneous values we can give it to the RNN framework.
Yeah.
So pre-processing is the
Yes. 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 So, I mean, see, when we deal with the biosignal, it's always recommended to have a pre-processing. I'll tell you a very specific reason. Now, this will give you or filter out your data at the beginning itself. No, so sometimes what you do, considering the amplitude is very low, you amplify them. Now, if you don't do a pre-processing, what will happen? You will amplify the noise also. Now, when you amplify the noise, it is unwanted work for a neural network or an AI to do that. If you really don't you want to reduce the load of that, there are a few hardware level or few basic filter which you can just put it into, and especially for those where you already know the frequency, it will help your system to work smoothly and on a smaller size. Now, considering, so I mean, why it is one more parameter I want to add for the pre-processing, because so now let's say, for example, you want to design one device which you want to place it on the someone head, right? So that those particular eclipse can be detected. So if you really want to do that, your device has to be very small. Now, if you want a smaller device, your chip and the whole circuit has to be smaller. Now, if you will make your AI to do more work, that means you need a more processing power, means a bigger chip and more power in terms of voltage also. So if you really wants to reduce that power at some extent, there are very small power efficient pre-processing chips, or as well as the circuits are there, or even a smaller chip which come with a small, just a very small algorithm which will remove unwanted signal at some stage, and then it will give you a little bit filtered data so that you can design your system in a smaller scale. I'm telling you the device designing perspective. So that's why at some level it's must. Okay, so one more. Okay, what do you mean by class imbalance? I mean, I think I did not understand that the question there.
see obviously the class imbalance in the sense number of sample data available in each of the class. So
Okay, okay,
obviously we
okay,
have to do some kind of augmentation technique, like we do have like literature, Addison, adaptive synthesis, and then we can use many upsampling methods are available, so that it's always better to have the equal number of samples in all the classes. Suppose if
yeah, 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 true.
we do three class classification, normal, ictal, and interictal, it's better to have like by using technique like synthetic minority oversampling technique, SMOT. It's
Yeah,
very familiar for tabular type of data, where you have the features tabular data set, and image based augmentation technique. We can use generative AI like GAN and all. We can use it to have generate synthetic images, or in general we used to say as a first step, data imputation you are supposed to do. So where and all data is missing, the missing data we have to replace with depending upon the but that particular feature type, we have to replace with mean, median, mode, or something, whichever you feel. Or we have to more number of data is missing means we have to remove it also. So data imputation, data imbalance, we have to overcome. That is a that itself comes in pre-processing along with traditional like technique like as Sir said, filtering. We have to do some kind of equalization, that is also important, which include rectification, something like that. uh,
yeah.
yeah. Thank you, sir. Thank you very much for your wonderful session. Thank you,
Thank,
sir.
thank you, sir. Thank you, thank you all. So yeah, thank you very
Yes.
much. Yeah.
Yeah. Yes. Thank you. Dear participants, we will join at 8 o'clock for the session from Varun Gopi sir from NIT Trichy. Tomorrow we have session scheduled from 2 p.m. itself, and the sessions will be taken by Dr. Moganavel from DRDO, followed by Nisha, Dr. Nisha from MatWorks, and we have Dr. Vanadi Sundaresan from IAAC. So tomorrow session we have very eminent speakers. Tomorrow, you please all of you make yourself free to join at 2 o'clock itself. Tomorrow we have also scheduled for a test. So you have to after the session 2 to 3:30 first session, then 3:30 to 5 second session, 5 to 6:30 third session, 6:30 we will enable the quiz, and after the test we have the validation session. Thank you. Tomorrow we
So,
have yeah, please.
sir, sorry, I think there is one question I just wanted to answer it.
Yes sir, you can,
Yeah,
yeah.
so I think Miss Lisa have asked that question. So yes, we can detect it not just a minutes. I mean, we can definitely detect even the hours before, but it depends on the epilepsy type or a seizure type. There are a few things which happen very long. Like if a person is going to have the extreme of that seizure, the signal, the pattern will start coming way before. It could be a very small tweak in the body, or which can be easily detected by the well-designed algorithm minutes before, and a person can be notified. But we cannot stop it at this level. I mean, stopping. If you are asking a stopping, meaning using a device itself, I'm not sure. But yes, there are medicines which can be given in advance so that the person will not go to the extreme case. So yeah,
Sir, good evening, sir. I have a question.
yeah, please.
Sir, I have heard about one thing like basic about Caesar. Like once a kid, like a 5 year old kid or below 5 year old kid, if the kid is having a Caesar,
Mhm.
the doctor said that immediate increase in the temperature, body temperature, will lead to the brain shaking moment that causes the Caesar. Is that true, sir?
Uh, okay. See, we can see in the different ways. So what happened? Our brain have a one very specific thing. Our body can increase the temperature to sometime our when we have a fever, sometime 101 or 102. But our brain should never, and inside our brain we should never increase the temperature. Now why the doctor is saying at that level, that could be one of the reason is, I mean, I don't have a data backing for that, but based on the information I have on the how our brain and how they control the temperature, what I can tell here is, so once you increase the temperature of the room, our brain at sub level get little busier to control that the body temperature. That could be the reason of reducing the unwanted other signal. That could be the reason based on that information, because our brain cannot go above 37. Once it go above 37, we will get a brain damage. Yeah.
That doesn't match with the body temperature. Only the brain temperature will be like somewhat.
Okay. So okay, let me put it this way. So suppose, let me put it in a little different way as we are discussing now. Suppose there is a kid, he is showing a tantrum. Now there's a two way of doing it. Either we can just scold him, or that is basically giving a medicine, or we divert him for something else so that he will shift his focus from there at some scale, doing some other activity. So this could be the case here, same case here. So our brain is generating unwanted activity because at that time our brain is in the normal condition, just relaxing condition, generating only the beta or gamma wave or alpha or beta wave. But once you increase the temperature of the room, now the priority of the brain become controlling the body temperature, because outside it is too hot and he has to generate the internal cooling system. So it got little busier there. So you can reduce the seizure or unwanted activity which was previously brain was generating at some level.
Okay, sir. Thank you.
Yeah. Okay, so yeah.
Thank you, sir.
Thank you very much, sir.
Thank
Thank
you.
you very
We
much.
all
Yeah.
will meet at 8 o'clock. Thank you.